In this video, we will do several examples of factoring trinomials where there's more than one variable involved. So our goal here is to factor each trinomial completely. So anytime you've got a lot of stuff going on, numbers, variables, multiple variables, always look for a GCF that you can factor out first. There might not be one, but if there is one, it can make life a lot easier. So in this first example of negative y cubed z minus 7y squared z plus 60yz, I noticed that all of them have a z, right? And there's a negative out front as well. And all of them have a y, right? So the smallest power on y is just 1. So we could pull a y out as well. All right, so we will pull out negative y z, right? And we can't pull out a number, right, other than negative 1. But let's see what pulling out that GCF does, okay? So negative yz times y squared gives us negative y cubed z. All right, what would we have to multiply negative yz by to get negative 7y squared z? Positive 7y, right? So negative yz times positive 7y gives us negative y squared z. Now, if we're pulling out negative yz from 60yz, we're going to have minus 60, right? So pulling out that negative changes the sign on all of the terms. Okay, now we're going to look at that trinomial of y squared plus 7y minus 60 and ask ourselves, what factors of negative 60 add to 7? So now think about the signs on these things. We're looking for two binomials. Y times y is y squared. The 60 is negative, right? We're subtracting 60, so that means that one of them has to be positive and one of them has to be negative, right? Positive times a negative is a negative. Okay, so let's think about factors of 60. 1 and 60, 2 and 30, 3 and 20, 4 and 15, and 5 times 12. Okay, well the difference of 5 and 12 is 7. So if I have positive 12 and negative 5, 12 minus 5 would give me positive 7, right? So I'll have y plus 12 and y minus 5 as factors. Okay? Now, I always like to check. So negative yz times y plus 12 times y minus 5. Will that give us negative y cubed z minus 7y squared z plus 60yz when we're done? All right, so leave the GCF of negative yz alone and FOIL the y plus 12 times y minus 5. So in that foiling, we'll get y squared minus 5y plus 12y, right, in the middle, outer and inner, and then the last 12 times negative 5 is minus 60. All right, so clean up that middle term. Negative 5y plus 12y is positive 7y minus 60. All right, so now we just need to distribute the GCF through, right? So y times y squared is y cubed, so we're going to have negative y cubed z. Negative yz times 7z is minus 7y squared z. And negative yz times negative 60 is positive 60yz, which is exactly what we started with. All right, I'm going to give us a little boundary there. Now, let's look at x squared y squared minus 12xy plus 27. So in this case, we don't have a GCF that we can pull out, right? Because that last term is a constant, just 27. and the first term doesn't have any numbers in it, so there's nothing that we can pull out here. But we notice that we've got two variables going on, both the x and the y. Okay, so let's think about this for a moment. You know, just like on the other examples when we're factoring into the product of two binomials. Usually, like if you've got just the x squared there, you'd say, well, x times x is x squared, so we'd have an x here and we'd have an x here. But in this case, we also have a y, right? So xy times xy is x squared y squared. All right, so that solves that problem. Now, 27 is positive, right? So either they're both going to be positive or both negative, right? The numbers we're looking for are factoring numbers. But the middle term is negative, right? So I'm voting that they're both negative. Yeah? Okay, so now let's think about this. Factors of 27 that add to negative 12. Well, 9 and 3, right? And if they're both negative, negative 9 and negative 3, as we said that they would have to be, negative 9 minus 3 is negative 12. Okay, so xy minus 9 and xy minus 3. Okay, now if we check this, if we FOIL it back through, we should be golden. All right, I'm going to come down here because I'm out of room. All right, so x times x is x squared, y times y is y squared, so we get x squared y squared. Now, for the outer, I have negative 3 times xy, so minus 3xy. And on the inner term, negative y times xy is minus 9xy. And negative 9 times negative 3 is positive 27. Okay, so again, we're just cleaning up that middle term. X squared y squared minus 12xy plus 27. So now let's do this next example. It's x squared plus 4xy plus 4y squared. All right, so in this case we've got an x and a y. We don't have a common factor we can pull out. But notice that this is a little different than the previous example in that there's a variable squared in the last term too. It's not just a constant. So let's take a look at this. If we're going to factor this into the product of two binomials, I know that x times x is x squared. We're adding everywhere, right? The middle term and the last term are positive, so we know we're going to be adding here and here. And I know the last term, to get 4y squared, I have to have y times y, right? And then we need to figure out what coefficient goes on that y, right? So if I'm looking for factors of 4 that add to 4, that's going to be 2 and 2, right? So I've got x plus 2y times x plus 2y. The other way that we could write this is x plus 2y squared. And now if we check this, x plus 2y times x plus 2y, FOIL that out. So we're going to have x squared as our first term. Outer term would be plus 2xy, right? X times 2y is 2xy. And our inner term is going to be 2xy. And our last term will be 4y squared, right? 2y times 2y, 4y squared. And so let's clean up that middle term. X squared plus 4xy, right? Because we have 2xy plus 2xy. And then our last term here would be 4y squared. Is that what we started with? Indeed. Very good. All right, so this last one, there's a lot to it. Negative 2x squared y squared plus 18x squared yz plus 72x squared z squared. Okay, I actually see three variables in this, x, y, and z, right? And all three of those terms have numbers, okay? And there's a negative out front. You always want to factor the negative out if that's the case. Okay, so let's look for a GCF. We're going to come down here. First of all, negative 2 is a factor of itself, and of 18, and of 72. So I'm going to pull a negative 2 out. And while I'm at it, what's common with the variables? Do they all have an x in there? They actually all have x squared, right? That's common to all of them. So I'm going to pull an x squared out. And let's see, do they all have a y? No. Do they all have a z? No. The first term doesn't have a z. Okay. So if we pull out negative 2x squared, what are we left with? So if we pull negative 2x squared out from negative 2x squared y squared, we're just left with y squared, right? If we pull negative 2 out of 18, we're going to have minus 9. Okay, the x squared is pulled out, and then we're going to have yz left. Okay, now negative 2 times negative 36 is positive 72, right? And we're pulling the x squared out, so the other part of that is z squared, right? So that last term will factor to negative 36 z squared. Okay, so now the trinomial that we have to factor looks a lot like the previous example that we did, right? So I've got negative 2x squared, don't lose that GCF, and then I have to factor this trinomial into the product of two binomials, if it'll go, right? So y times y is y squared, and now I'm looking at that last term, it's minus 36z squared. So that means that one of these is going to be positive and one's going to be negative, right? Just in order to get that last in the FOIL to be a negative. Okay, so then, and I know z has to be part of it, right? Because z times z is z squared. It's just what the coefficient on z is going to be, right? So I want two numbers that multiply to give negative 36 and add to give negative 9. Well, there's 1 times 36, there's 2 times 18, there's 3 times 12. Now the difference of 3 and 12 is 9. So, and I want negative 9. So if I have negative 12 plus 3, that should do it, right? Okay, so I'm going to have y plus 3z times y minus 12z. Okay, and then of course we'll check that. So when we take the negative 2x squared times y plus 3z times y minus 12z, leave the GCF of negative 2x squared alone and FOIL the rest. So we'll have y squared, y times y is y squared. The outer, y times negative 12z is minus 12yz. The inner will be 3z times y, which is plus 3yz. And then the last, 3z times negative 12z is minus 36z squared. Okay, so we're going to clean up the middle term there. So we got y squared, negative 12yz plus 3yz is minus 9yz. And then we also have minus 36z squared. Okay, so now all we need to do is distribute the GCF through. So we have negative 2x squared, y squared, plus 18x squared yz, plus 72x squared z squared. Okay, is that what we started with? Take a good look at it. Negative 2x squared y squared plus 18x squared yz plus 72x squared z squared. Yes, it is. So also on all of these, you'll notice that I'm really good at checking, each one. Now, as you're doing homework, are you going to want to check each one? You can let some of that go. But certainly if you're in an assessment situation, you're taking a test, very good, reasonable, prudent idea to go ahead and FOIL that thing back through. Make sure that you're getting a statement that's equivalent to the one that you started with.